Welcome to a video on evaluating a function and determining its domain and range from a graph. We'll be answering these 5 questions using the graph of a function. For part A, find f of -2 and f of 1. For f of -2, the input value is defined as -2. We need to determine the output value using the graph of the function. So notice that at x equals -2, the y value there is 0. Likewise, f of 1. So when x is equal to 1, the output value, we're going to use the solid dot since open circle means that it's not defined there. Hence, the output value is 2. For part B, find all values for which the function value is 0. So this is saying that when y is equal to 0, what are the x's? What are the x values? One way to do that is to use a horizontal line and place that line where y is equal to 0. So let's consider using the top of the ruler. And then where the ruler intersects the graph, we want to locate those x values. So here we have the line intersecting the graph at this point, and this point. Hence, identifying those x's, those values are -2, 0, and roughly 1/2. Now let's move on to letter C. Find all values for which the function value is equal to 8. So when the y value is equal to 8, what are the corresponding input values? So again, similarly to letter B, we're going to take the top of the ruler, place that at the value 8. Here's when y is equal to 8. Notice that the ruler intersects the graph at the following points. So this entire segment, including this endpoint there, since that's a solid dot, that looks like an x value of 3 where it ends. And then we want to include all these x's. Now, this is an open circle, so we don't want to include that. So we're going to use interval notation to represent that entire set. So all values of x strictly larger than 1 all the way to the number 3. So using the interval notation, that would be from 1 to 3, inclusive of 3. All right, and now letter D, determine the domain of the function. So recall in one of the videos to determine the domain of a function graphically, we can use a vertical line and basically slide that vertical line all across the graph. So this time I'm going to use the right edge of the ruler to determine the vertical line there. So we place the ruler here. Notice that the function is decreasing, but it's also getting wider towards the left. So the graph is defined from -infinity. It's still defined there. And then at 1, there's a jump, but at 1, there's that solid circle. So that means it's defined at 1 as well. And then from 1 on, that constant piece right there. So it's still defined. And then at 3, again, due to that solid circle, that's still defined. And then from 3 on, we have that ray, which means that the graph is also defined from 3 on. So the domain of this function is the set of all real numbers. In other words, the function is defined everywhere. And so in interval notation, that would be from -infinity to +infinity. And lastly, for letter E, determine the range of the function. So graphically, we can use a horizontal line and basically slide that horizontal line up and down. Starting with the bottom of the function, notice again the arrow is pointing downward, which means that the y value is defined there. Starting with -infinity, still defined, the ruler still intersecting the graph. And then at 7, obviously it's at its peak right there on that curve. Now, in between 7 and 8, notice that the ruler, the top of the ruler, isn't intersecting the graph at all. So it's defined up to 7, including 7, and then there's a gap, and then it's defined at 8, and then again, between 8 and 9, the graph does not exist there. So let's start again at the bottom, starting with negative infinity up to the number 7, inclusive of 7, and then it's undefined between 7 and 8. Then it does include 8. So we're going to union this subset with only one value, which is 8. So if it's a single value, use this notation here, which is a braces symbol, including the value 8, and then it's not defined between 8 and 9. At 9, it's still undefined, but from 9 on, the graph exists. And therefore, union using open interval, 9, all the way to infinity. And so this is one way to determine the range of the function.